We are back on the road. Simulation business tour return across Poland and Europe, bringing decision makers, engineers and universities together around one thing: making better operational and investment decisions before they become expensive mistakes. Simulation Business Tour is a series of small, focused in-person events where real production and logistics processes are tested in simulation. No theory, no generic presentations, just concrete scenarios, real data and clear insights you can actually use. You will see how changes in automation, resources, layouts or buffers really affect performance, risk and costs before anything is built or bought. Registration is now open. Seats are limited because the value comes from discussion, not crowd size. If you are responsible for decisions that matter, secure a spot now and join us at Simulation Business Tour 2026.
Okay, so today what we're going to do is we're going to continue working on our automatic warehouse. So we try to pick up where we left on our previous session. Okay, so as you can see, this is where we finished previously, and we want to continue with it. Okay, so before we start again. Welcome everybody, my name is Dawid. I work with FlexSim for almost 15 years in FlexSim InterMarium, and we as InterMarium we're authorized reseller of FlexSim in Central and Eastern Europe, and also of course provide the support, teaching, training, workshop for our clients and for FlexSim users around the world. So in this webinar, we are working on automatic warehouse. This is second part, I think 3, maybe 4 parts, and we should be able to finish this warehouse. We're doing this, thanks to your suggestions, more like a workshop. So we're doing this warehouse, a lot of users requested, so we can do the automatic warehouse, and this is also how we work with our clients. So if you have any case you want to do, maybe you want to have some help with modeling on your cases, we can always set up a call or make a workshop where we try to help you build something together with you, as I am building this right now with you.
Before we begin, a short message from InterMarium. We build simulation models tailored to your company and your processes. Production, warehouse, internal logistics. If you want to check how your system really works, we can model it for you. And if you already work with FlexSim or want to build these skills inside your organization, we also provide professional FlexSim training from beginner to advanced levels and project-based courses. You can find our full offer at intermarium.com.pl. Now let's start the webinar.
Let's join our webinar. If you have any questions during my model building, please don't hesitate to ask them. Just write on chat, hey Dawid, can you maybe show something? Can you tell me how it's done? I have some different things, how I should be able to do it. Please don't hesitate, just write them on the chat and I'll be very happy to answer them. Okay, so let's start. So as I mentioned earlier, this is where we finished previously. We had the working SRS, working rack structure, working conveyor base. And we have base stock table, so we can generate the base stock in our warehouse according to this table. This is what we have. What we want to do today is we want to bring in more data. So we want to have inbound and outbound data in this. Because right now we just have the source, and the source just generates the pallets, and we want to have some table inbound timestamp. Let's say we want to try out some historical scenario or some generated scenario with the given timestamp, with the given product. We want to have it all. And also we want to create the outbound movement, because right now what we are doing, we are just putting the pallets into the racks. And so we're doing the put away logic, but we also want to have the logic that whenever I do the put away, maybe the ASRS, there is a need for some palette, and maybe ASRS can pick it up and move it on to our conveyor system. Okay, so this is what we're going to do today. So more data, more input. So in the Excel file, I have the base stock. This is something we are already importing into our model. And I also want to have the inbound table. So what I have here is I have some palette. On the palette, there are some number of goods, 5 in this case. We're going to represent this as a label, and we have a timestamp. So I want this palette, let's say, to appear in my system at this time. So this is the time I'm going to use here. So at 20-second and 26-second mark, I want my palette to enter my system. Okay, I have this for inbound and I have this for outbound. So I also want to take from my warehouse this SKU at this timestamp. So this is where the request is going to appear. So at 107, I want to request this palette from my warehouse. I don't know where it is. It is somewhere based on the base stock table. I want to request it. And this is what we're going to do today. So I have this in Excel. We already created some Excel import interface before. So what we need to do now is we have to create global tables from our data. So I will call it inbound. Let's start with inbound. So this is my table. I need to check how my Excel sheet is called. It's called inbound. I'm going to copy it. Then I'm going to go back to my model, the Excel interface. I will add one more info line. I'm going to call it inbound from the same workbook. Here you can choose the new, and then the user can choose the next sheet. Maybe it's different Excel file, or blank. And if I choose blank, then it's the same Excel file as I chose before. So if I know that I have all those data in one Excel file, I can choose blank, and then we just one by one import different sheets from it. So it's the inbound sheet, and I want to put this in the inbound table. I don't have headers. I have the columns, so everything's okay. I can now click import to this Excel, and now I have those data from Excel file. So this is my inbound table. I have now base stock and inbound, and those are the same data I have in Excel. Okay, so now we have a data. So now we can start working with. So we have a data. Let's go back to the model. So before I had the source, and source that just generates palettes for me, but it's no longer the case, because I want to generate those inbound palettes from this table. So I need to write the logic to create it. What I usually do is I use the queue, and I'm generating everything on this queue, and then automatically it's getting added to the entry channel for the compare. Is it a bit easier for me because then I can track the backlog. Maybe if I have some blockage, I can track how many products is on the queue, meaning there is no space for them in my system. So it's a little bit easier if I do it like this. And of course, is it better if I want to handle, let's say, the overflow in a way? So I have the Q1, let's call it, I don't know, inbound flow. So this is where I will start my inbound flow. I want to generate palette on this queue, and then using the port connection, is going to be automatically moved on my conveyor system. So this is the object. Now let's create the logic in the process flow. So what I want to do, I have this inbound table. Maybe I will just dock it for a moment here so I can see it. And I want palette to generate it here with this SKU, with this quantity, and at this timestamp. Okay, so how can we do it? There are multiple ways of doing it, to be honest. And one way, for example, is you can use the source, and you can, for example, get this part of Excel file to be stored using the Excel interface. So if you structure your table in Excel correctly, it can be transferred right here in the schedule source. It looks easy, but I would say it's not very good, let's say, in terms of performance-wise, this can get really slow. Yeah? So what I usually do, and also multiple ways of doing it, we can generate as many tokens as I have rows in my table, and then makes a delay. And when the delay finish, I will create the palette. But then the issue also with performance that, okay, but in this case, I have 1,000 rows. But if I have, let's say, 1 month worth of inbound, and each time I'm generating the inbound, I need to create as many tokens as I have rows, and I have 10,000 rows or 100,000 rows, then the model will be very slow at the beginning because you need to reserve a lot of memory for all those tokens, and because it's 100,000 tokens. So I think what I usually do is I just generating 1 token. This is my 1 token. I'm going to go through this table step by step and creating a delay that are the difference of these 2 values. So for example, first is 26, it's easy, but then for the next one, it's going to be 32 seconds. And because I will have 1 token, I will just move in a circle, move in the loop. I don't need to have as many tokens created. And let's say performance-wise, overall, it's the same because I will generate 100,000 tokens. But because this, let's say, performance is distributed along time, the model will go smoother in the beginning. And usually, especially when you're building model, you're going to reset and run it a lot. And you don't want to each time reset, run. You don't want to generate this thousands of tokens because it's make model slow. You need to wait a few seconds. And if you wait a few seconds every reset run, it will be getting on your nerves every second, every time I need to wait. Yeah, so let's do it like this. So I will generate 1 token. And in this 1 token, what I need to do is I need to create what I want to create. Let's do it now. So I will have the assign labels here. And in the source, I will create 1 label. Let's call it inbound row, starting with 1. So this is my first row. So on my first row, maybe start like this. I have a delay. So on the first row, I need to have a delay because I need to wait this time because first row is different because I don't know the difference between those 2 values. So in this case, what I want to use here is I want to use this value from the first row. So token dot inbound row inside. So now when I reset run, we have 26 seconds as I have in the table. And then after this time, I want to create the palette. So I will create an object. Let's call it create palette. Now, this is going to be our palette. So I'll go to flow items and choose palette. We already created before in flow item bin. There's going to be 1 palette. Let's call it palette. It should have 2 labels, SKU and quantity. So it will have the SKU. I will sample this and change token dot inbound row. You can also do it if I have the quantity here. You can also do it by choosing this option, go table, by global table lookup, and then fill this out manually. You can also do like this is the second column. It works the same. But the main difference is that with this, if I have more labels, I can't copy it. Yeah? Because it just copied the header, not the logic itself. That's why I prefer choosing it like this and just changing the row value, because then I can, if I have more, I can just copy it and change the column, and it's much faster, especially when you have a lot of parameters that need to be moved from the table to the model. Huh? It works virtually the same. I have these 2 parameters. So at this time, 26 seconds, I want to create the palette, and the palette has all this parameter. And where I want to create it, I want to create it in an inbound flow. Technically, you could do it at this transfer and to transfer, it works the same. But as I said, I prefer having the queue. It's easier for me to track it if I have any blockages or I don't have enough space on my system. So now, if I reset and run this model, after 26 seconds, let's make it faster, pallet arrives, and this pallet has SKU and the quantity of this SKU as I have it in the table. Yeah. So this is what works for me. Okay, so if I have it, this is, let's say, first loop. Now I need to loop it. So what I need to do? I need to do here is I need to create the assign labels because I need to increment the inbound row. I need to increment, yeah, because I was first row, that is second, third, fourth, and so on, and so on. So I want to increment what? In this case, inbound row, increment label by 1. So I want to increment. If I increment, then I need to create a delay. So it's going to be delay, let's say, between pallets. But in this case, this delay is a difference between 58 in this case and 26. So I can have it and just copy it, and it's minus and from the previous row, so -1. Isn't it trick? Yeah, so it's this row minus the previous one. So then I have the correct delay, correct calculation delay in between those two arrivals. And then if I have it, I need to loop it. Okay, so create me a new pallet. So now if I reset and run, at 26-second mark, I will have one pallet. Now I have 58 is exit times of 32 seconds, as I have in the table. Token will loop back to the create pallet. Again, have pallet, in this case, 8A2 is working, 2021 is working. Yeah. So in this case, I have I can use the historical data, for example, from my WMS system and the system, or I can create my own scenarios in Excel using timestamp, and I can generate the flow based on historical data. Yeah? It's pretty easy, as you can see, to do it. You just need to have a good data. What you need to remember is that at some point of the simulation, this table will finish, and because I have only 24 hours of data in this case. So if I have 1,000 rows. So if I get the inbound rows value as 1,001, it will return me an error in FlexSim because I don't have data in this row because I don't have that many rows. So usually you need to be sure in this case that before you start this calculation, you need to check if inbound row is still less than the numbers of row in the table. You still need to check. So we will write the conditional decide and tell that if I have the global table, you can write it there. We have number of rows. So the stop number of rows still needs to be greater and equal to token inbound row. And if this is true, so let's say if my inbound row is 950 and I have 1,000 row, still good. But if this is 1,001, I don't have that much data, then in this case, I need to break it. So in this case, I want to destroy token. I want to stop this logic. I don't want to generate anything more. It's also good if you do it like this, because then you finish the data. So for example, what you can do here is you can create some stop into the model. You can stop the model. So let's say you generated everything. I want to stop the model whenever I have the last record on the data, or after some time from the last record. Yeah? So you can have here dynamic stop of your model because you calculate everything, and you never know when is everything because you can have dynamic set of data. Yeah. So in this case, you have this flag control point. Okay, you generate everything, and then I want to stop the model, and maybe run some calculation. This is something you can do here because, with this decide that you've generated everything you needed in this model. Yeah. And now it will loop back in the logic and generate different palettes. So this is the inbound. Yeah? So inbound is good. For future reference, if you want to stop the model in a given time, you can go to the script. And in the script, if you just write stop with bracket and semicolon in the end, this is your stop. So you can, for example, if I put it there, here, reset and run, the model will automatically stop at this point of the logic. Yeah. If I run it again, it's like pausing, then the model will continue. So you can maybe have some stoppage or see when something happens. It can be done via stop. It can also be done if you want with breaker. So then the model will also automatically stop at this point, and you can debug your process flow, see what is happening, maybe put a little more thought into the logic, see if this is working correctly. Okay, we have the inbound. It's working fine. I will put some frame over it, container, so I can have, this is my inbound. Okay, so I have the inbound. Yeah, so I generate the palette, and the palette enters the conveyor and then moves to the conveyor. Then I have this logic here, so I can understand what is happening, where I'm going. Okay, this is good. We have the inbound. Now let's add the outbound. So I have the inbound. This is okay. So now let's add the logic for outbound. So go back to Excel. I have the typo here. Fix it. Outbound logic. Outbound, I have the data, SKU, when I need it, because I need to remove a palette from my warehouse in this case. So I will also go to the global table, create outbound table, add this to the Excel. So again, I want to create one more export file. It's called outbound. Outbound table data is outbound. And I want to import it. It asks me which file. Not sheet. So yeah, I have the error. Why? I changed the sheet name, but FlexSim doesn't say. Why? Because I didn't save the Excel file. If you make the changes in Excel file, FlexSim doesn't see it, not until you save the Excel. Yes, it's important to save it. And then if I import it, then it should be all right, because I've changed that sheet name. Took me a few seconds. I have now inbound and outbound table. Okay. So we're good. We have all the data we need. We have the inbound, outbound, base stock. Now we can start playing around. So I need to tell FlexSim that I need to get this palette at specific time. So we can more or less use what we already have. So we have the inbound. I will copy it here. And in this case, I'm going to start making with it the outbound logic. Okay, so I have inbound, let's call it outbound, because let's say general framework will be the same. I have one token looping through this table and generate the request for a given table. So the source is the same. Maybe I will change it to outbound row. We can understand better what we are doing from the outbound row. In this case, I have a first delay, and this first delay is in the outbound table from outbound row. Yeah, outbound row. Yeah, this is my first delay. Difference is it's in the second column because I don't have the quantity. And so this table is structured a little bit different. So it's going to be on the second row. And here is where the change is going to start. So in this case, I need to look for the palette in my warehouse. So in this case, I will create some assign labels because I need to know which SKU I'm looking for. So there is some SKU. And this SKU, let's call it SKU, is in the table. So again, I can do like this in outbound, in the row, and the row is outbound row, comma 1. So if I reach and run, I know that right now I need to get the pallet IQRS. This is pallet I need. So it's IQRS. So what I need to do is I need to find this pallet in my warehouse. In this case, we're going to use the find item logic. Find item logic. And what is the query here? I don't want to have any item. I want to have a specific SKU. And I want to match the item label. If I find item, you can look for a product based on the item label, so what is on the pallet, or you can base on the slot label, so in the given area of the warehouse. Yeah, so you need to get items, you need to have a specific item, or anything, for example, from the given area, or any combination of both in this case. So in this case, I'm going to match it with the item label. And the item label is SKU, and I want to compare with the SKU. You have $1. $1 is the parameter for this query. So $1 is, in this case, token. So $1 SKU is the same as token.sku. Yeah, because you have the parameter, you cannot mix FlexSim language and SQL. In this case, we need to pass the parameter somehow to the SQL query. And the $1, you can pass it from the token perspective. You can have more of this parameter. It depends how complicated your query is. Yeah? So if I reach and run, you can see our pallets is having the SKU. So when I'm looking for a specific SKU, and here assigned to, I want this to be token pallet. So if you find the item with the matching SKU, I want to store it in token.pallet label. So reset run. Let's see if this is work. Yeah, I have the pallet here, so it was found. If you want to see it, you can click on it. You can make it. This is the pallet. Here is there in the warehouse. Sometimes I'm building the model. Of course, it's good to have the racks, but sometimes I have the group. Yeah, I have group for racks, so you can click on any racks and change the visualization to the wireframe. So you can see what is inside the racks. If I recently run it, and you have this situation, then if you click on the binoculars, you know which pallet is it. You can also click here, so it will have the red outline. Yeah, so this is the pallet I'm looking for in this case. Okay, so we have the pallet. We now know what we want. We want to have this pallet. But how can we force the ASRS to take this pallet? So in this case, okay, we have the inbound, the outbound. Now we need to change the logic, how we are going to control the ASRS. Because right now the logic is here, you have the ASRS, and it just takes the pallet. And it takes the pallet, and this is it. We acquire it. But for example, usually you want this to be in double cycle, mixed cycle. So if the ASRS is taking something and put it into the rack, I should check maybe there is something to be taken out of the rack. Yeah, because there is a request here for this specific item. So we need to handle, let's say, the priority of logic, how the ASRS is working. We're going to do here the basic framework, but basically you can, with this, it's pretty universal, and you can put more and more parameters there if you want to create more sophisticated logic about how your ASRS are working. Okay, so in this case, what do we need to do? We need to create the logic from the perspective of the ASRS. So right now, let's say we are pushing the pallets onto ASRS, and ASRS are taking those. But we will write the logic from perspective of ASRS. So let's imagine that I am the ASRS. So I am the ASRS, and I'm waiting for a task. Yeah? And if I have a task to put something, if I say maybe if I have inbound task, okay, I will go and take it. if I finish the inbound task, I will check maybe I have the outbound task I can do. If I can do it, I will do it. So I will take the pallet from the rack, brought it here, and then I will check, okay, I've just taken the pallet out of the rack. Maybe there is something I can take as an inbound task, and so on and so on. So we need to handle this logic like this. And we will do it with the list. So we create the list of tasks that my ASRS is having. And then based on this list, I will choose which task should I do next. Because I can do it right before, or I can, for example, tell the ASRS, okay, where you are right now, and find me the closest pallet that needs to be taken out of the warehouse from where you just loaded different pallet in this rack. And so we can try out the different optimization in terms of how the ASRS should work. Okay, so we need to do the list. What is list? We can treat list as dynamic repository of things in FlexSim. So the list lets you handle whenever you need to choose something based on any parameter. So in a situation, I need to choose, and in this case, ASRS is choosing what to do next. And it can have multiple requests. Maybe we have a situation, what is more important for me? Outbound or inbound? Should I start with outbound or should I start with inbound? Yeah? All those questions can be answered using the list. So what we need to do at the start is we need to create the list. In this case, I will create a global list of items, and I will call it ASRS tasks in this case. And I will remove all parameters for now. I will create just the list, and I will show you how to push things on the list, and then we're going to mark it. So on this task, we need to know if this is the inbound or outbound task. Okay, so I am ASRS, I have the list. So now we need to write the logic to put the task on the list. So in this case, what we need to have? Let's start with outbound. So I will create here by list from the process flow. This is the list. I will call it ASRS tasks. Make the connection to my list. And okay, let's go to outbound. You have the item. Yes, I have the item. So now I need to push this item to the list. Yeah, so push, so create, in this case, ASRS task. And push value is going to be my pallet. So if I listen run, I'm going to drop here. And now on my list of tasks, there is one pallet waiting to be taken out of the warehouse. Now, what I need to know about this pallet in order to, let's say, handle the logic from the ASRS perspective. First, I need to know what kind of task it is. So in this case, I find the pallet, I will mark it. So on the pallet that I've just found, let's call it task, right? I will create it, and this task type is, I will call it outbound with the string. It can be inbound, outbound, I know, reshuffling. What kind of task it is? I'm going to have somehow, we need to name it somehow. So it's an outbound task. Now, if I release and run, nothing changes. But I know now this pallet has the task type outbound. I know what kind of task this is. And from the list perspective, I don't know about. So we need to go to the list. You can go to the advanced here, or you can go to the global list. We create a label field called task type. But make it dynamic. It could change some way. And now if I recent run it, because I've added this field, now on my list, I know that I have one task of unbound time here. Okay, so right now, this is what I know. Okay, one pallet outbound. Now let's do the same for inbound. So I am here, I'm stopping the pallet. I won't call the ASRS yet. For a moment, I will just move this here and copy this logic. In this case, we have the same name palette. That it's good to, let's say, have some kind of standard to always name palette. And this way we can more easily copy between different logic. So this is going to be inbound of different task type. And I also want to push it on my list. So now when I reset and run, you will see in a moment, because I don't have the logic of inbound, but after some time, on my list, there are multiple different tasks of inbound or outbound. This is what I have. Yeah? Well, I need to connect it here. And this logic, now you can see we have different tasks. So right now I have the list. I know what needs to be put into the rack, taken out of the rack. This is good. Now, what else I need to know to handle the logic? I need to know from the ASRS perspective. Let's still imagine you are the ASRS. So I am the ASRS. So I know what needs to be taken into the rack, out of the rack. This is good. But I need to know if this is my task. Because if I am this ASRS, I need to be able to identify if this palette is in my area of work, because I only take the palette from these two racks. I cannot take the palette from all the right side. It's not my area. So I need to somehow mark it that these racks belongs to me, to my area. Because if I'm looking for work, I'm looking for inbound or outbound task, but only from my area of work. So in this case, from my eye. So how can we do it? There are, again, multiple ways of doing it. We can do it from this log letter perspective in this way, or this one way of doing it. But how I usually doing it, because it's a little bit easier later on, I'll go back to that so we can see it, is I'm marking the racks. Because in the ASRS, they are always working on the two racks in this case. So what I will do is I will create on my racks, I will use groups to do it. On my rack, I will create a number label. Let's call it ASRS number. And click on one of the racks, clicking here, and then I can copy these labels on all of my racks. And now I need to decide which rack is belonging to which ASRS. So for example, these two racks are ASRS number 1. Okay? The other one is 2. So this is the second ASRS. Then is number 3. And then it's number 4. Yeah, this is how I have it. You can click here also, click on the compare properties, and then you have all different labels for all my racks. You can filter it, you can play around with it. So you have the list of all the racks. And if you, let's say, if you name your rack right, you can easily spot the difference or fill in the data almost automatic. Okay, we have it, so we know which rack is it, but we also need to tell the ASRS in which area it's working. So I will also have the ASRS, which will also be the group, in the group. Now you see how good it is to have a groups. I don't need to control-click some hidden objects there because everything is in the group. I will again create label ASRS number, let's name it the same, copy to every ASRS. So this is 1, this is 2, this is 3, and this is 4. So with this, I have this information. Now I need to put this information on the list for my task. So let's go back. So I have a task type. I know the palette. I know the task type. There is outbound. But now I need to also define what is the ASRS number I need to handle this task. So in this case, I know where the pallet is. Pallet's on the rack. So if I go token.pallet.up, I'm at the rack perspective. This is my rack. And I know that on the rack, I have the ASRS number label. So with this, I know where I'm going. So I know that this pallet is on the rack and the rack has this label. I'm going to use it, put it on the pallet, and then in the list, I can also have this label field called ASRS underscore number. So this is my task. Now I need to do the same here in my inbound logic. Yeah. In this case, I know the rack because I already have the label for it. Because when we are looking for the slot before, we also write this logic here. So from the slot perspective, what is my rack? So if I have my rack, in this case, I can also create ASRS number. It's going to be a little bit easier for me because token.rack and this ASRS number. It's easier to access the rack than to access the slot. And because rack is a modular and it can be treated as an object. So now if I make those changes, if I have this list, now on the view entities, I know what kind of tasks are waiting for me in this case, and which is the ASRS number that needs to handle this task. With the list, we can put much more information if we want to, let's say, create more custom logic. For example, I can very easily add advanced. I can add, for example, the push time. So if the push time is when the request was made. So you can filter all those requests, for example, or if request is waiting for more than X amount of time, handle it with a priority, whatever. List is very general. It gives a lot of different possibilities. Okay, we have inbound, outbound, we have the list. So now we need to write the logic from the ASRS perspective to handle this task. Okay, I am ASRS. So let's apply this logic. So in this case, I will use the schedule source. We have the ASRS, we have the group in this case, and I want to acquire it. This is going to be the same. I will acquire it. Name it ASRS resource. Yeah, it's good. I don't need to have it. So we can just like this, how we have it, ASRS. So let's maybe change the ASRS, the same. So I have the ASRS from this. I want to create a token for every member of this group. Why? If I copy it, I want this logic to automatically scale. So if I want this to working for 4 ASRS, but I also want this to work if I have 8 or 10 or 50, doesn't matter. I want this to be universal. And in resource fields, I already have the group. And if I copy it, I will also copy the object. They will still belong to this group because this is going to be copied with the copy. And in here, I also want to create as many tokens as I have members of the group. Here you can see, you can sample it. But if you go to script, you can sample everything. So I can go to ASRS group here, paste it. And now we need to write as group because FlexSim needs to understand that I want to have it as a group. And then you have the length. But it will create as many tokens as I have members in this group. So it will work if I have 5 ASRS, and it will work if I have more ASRS. Now I have 4, and let's say maybe if in the future I will copy this rack because I want to have more, I copy and paste it. If I reset and run it, now I have 5 tokens. Why? Because I've copied it, it's in the group, so the logic automatically scales. It's also a very neat trick. And if you do it right, if you do, let's say, one build ASRS Ali, then you can just copy it and the logic will still work. So let's say from the perspective of the size of number of resources, you will have the same amount of work in process flow. If you have 1 or 50 ASRS. Okay, so I've acquired a ASRS. Yeah, I've acquired it. Let's say I have it. I have the ASRS. I won't have the label there on the tokens. I won't have the ASRS number. And I know we have it on the ASRS as ASRS number. Maybe let's call it ASRS number. So now when I reset and run, I know I have 4 tokens. Each token has ASRS with the corresponding ASRS number. You have it, it works. So now what is the logic of ASRS? Again, I am the ASRS. Yeah? So in this case, maybe let's build it a little bit on the side, more space. I am the ASRS and I'm looking for work. I'm looking for work. So in this case, I'm going to use the pull from list. In this case, I'm going to use pull from list to check if there is a task for me in the ASRS task list. So it's going to be look for work. I want to look for work. And now is the question, what is the logic or algorithm of me looking for this work? And this could be whole simulation, that's how this works, especially if you are talking of AML AGVs or any fleet handling. Yeah? In this case, I will look for work. So what is the query I will use based on this list if I'm going to looking for work? So I'm looking for a pallet. Yeah, this is given. I want to move the pallet. And what is the query? So first, I only want to look for a work that is, let's say, in my area. So in this case, I want this ASRS to be the same. With list, you don't have the dollar, you have the puller. And in this case, puller means token. So if I puller there, it's the same as token ASRS number. So this will look for me for a task with the same ASRS number. So 1, 1, and so on. And for example, let's say my priority is inbound task. So I also only want to look for a task type that is inbound. This is what I want. I only want to look for a work that is my inbound task. If I have it, if I reset and run it, those tokens are waiting here because the list automatically handles waiting for a task. So let's say I will just put a delay there so you can see it. So if I reset and run, at this 26-second mark, you have this pallet. You can see it moved there and token jumped because now the ASRS number 3 has found some task, and this pallet is on the straight conveyor. You know, this is this conveyor. This is the ASRS number 3, 1, 2, 3. It's okay. So it found me the work. So now, if I have this work, if I know what I need to do with there, then I can handle the rest of the logic. So I need to do load and unload.
Great to have you with us. If you find this content useful and want to improve your simulation model or are considering implementing FlexSim in your company, please contact us at flexsim@intermarium.com.pl.
Let's see if this is working. Load. So ASRS will take pallet. It should work correctly, have the same names. 26 seconds. Builder token jumped, and the ASRS is moving to pick this pallet. And it took the pallet, and this is it, because this is the right data of the logic. Now, what could be an issue? Because now we need to unload it. So the ASRS takes the pallet and moves it onto the rack. But the information about rack is somewhere in this logic, and I don't have it here. Yeah, because it's different logic. Let's say I decentralize it. Yeah, because I have a different logic that is autonomous, that constantly looking for work, and I need to find a way to pass some information from this logic to this logic. And if I want to pass this information, I need to store it somewhere. And it's best to store it in, let's say, the common things. And in this two logic, the common thing is the palette. So if I put the information on the palette, why not to put the information about the rack? Because I have it there, it's on the token. So now if I pass the information on my palette, you can see in recent run, you will see in a moment with the palette right there. On the palette, after stopping the palette, if I click here, I see, okay, now I know on which rack I should go. So now I can use the information in my logic here, in unload, okay, let's check on the palette where it goes. So this information is stored on the palette. It's always a good idea, if we're talking about the, let's say, automatic warehousing, to store all those information on the object. So on the palette, on the container, or the quality, whatever. Because this is, let's say, the common part of every logic if you want to handle this somehow. So with this reset run, I should be able to move this palette from the conveyor to the corresponding racks. Is there? You can see the seconds also working and so on. And of course, what we need to do is we need to loop it. Yeah, this is what I will do. We need to loop it. So I'm still looking for work. With this, it shouldn't be like this. Just to show you, we have, let's say, the same end result as it here before. Yeah, with this. But now, let's say we have the different logic just for ASRS. In this case, we look for work. If you don't put anything else, the default logic, if I have multiple inbound tasks, for example, the default logic would be FIFO. So whichever task was first put on the list is taken with priority. So you have straight FIFO. You can then order it by different parameter if you want to, let's say, customize the logic for ASRS. So I'm looking for work. I unit load, unload. Now, what I should do is, again, look for work. I will look for work, and this is inbound. And it's going to look for work, and this is going to be outbound. And because if I am somewhere inside the alley, maybe there's a task for me to look of the outbound type. Good, outbound. Need to be careful here. FlexSim doesn't like a typo. So I'm looking for the outbound task. And now, if there is some outbound task that I can look for here, what do I need to do? Then the ASRS needs to take the palette, and this is okay. It's the same, because here assign to palette. So if you're able to find something that fits this criteria, then assign it to the token to the palette. It will be automatically changed, so we can have the same label. This value will be overridden. So I have the load, but now I need to unload it. So it's ASRS palette, it's okay. But then we have the ASRS palette, and we need to define the station. So we need to define where should I unload it. And in this case, because we are talking on the conveyor, we're doing this on the conveyor system, we need to have the entry transfer on the conveyor. You cannot put something on the conveyor without entry transfer. You can, but it won't work. So it needs to be an entry transfer. So in order for this to work, we need to add entry transfer on our every conveyor. So I will just do the A connection. It creates the transfer. I would delete the connection because I don't want to have those connections. I only want to have the exit transfer. You can leave it like this, or after making the connection, you can right click and you have the remove connection option. So it's up to you, whichever is better for you. So we have this connection. Now we need to create the logic so FlexSim knows which entry transfer is mine. And what I usually do is I'm making the connection to it from the rack perspective. Okay? This is just the most common approach we're going to do here. So the S connection, connect with both racks. Okay? So from the rack perspective, if you go to the list of center connections, ports, yeah, oh, I do it twice for this rack, so this one is okay. Yes. So on the first connection from the rack, there's entry transfer. And I will do it with every rack. You can see those connections. You can do it with racks. You can do it also with ASRS. Okay, it's maybe one less connection, but then maybe in the future you have a different entry exit transfer for different level or different racks. It can vary. And if using this standard connection, when you copy it, it will still work because they're also copying all different connections. So if I have this connected in the unload, I can define the unload point from the rack perspective. Yes, from the rack perspective. Now, what is the rack here? Because I have the pallet here. I don't have the rack. Yeah? The rack is, I need to define before I load that I have my rack, or maybe I will just do it. I will have the entry transfer. And what is the entry transfer? An entry transfer is token to pallet up. So pallet up is a rack because we are doing outbound movement. So when you start the outbound movement, the pallet should be still on the rack. So this is my rack. And if I have the rack, maybe make it a little bit easier. So I have the rack, and this is the rack. And if you have the rack, then we have the entry transfer. So from the entry transfer, I'll have token dot rack center object 3 is the third one because we have the ASS connected and the decision point for the routing on the conveyor. We can have all of this in one line, but let's say it's easier to read if we split it. So now we know the entry transfer. Let's call this assign label entry transfer. Okay, I take it, this is okay, but on unload, I want to put it on the entry transfer. And now ISR is moving, it's there. So now usually I want to loop it back. Still not ready, we have some work to do here, but let's loop it. And in reality, this transfer should be a little bit on the side because I want to slide the pallet from the side of the conveyor so we can move it like this. Okay, so now if I run, it still won't work properly. Why? Look, with the inbound task, you make the inbound, the ASRS, but now it waits for outbound on the list. It waits there until the task somehow will be added from this alley. We don't want this. We don't want to block ASRS. We want this to be, let's say, moving and checking constantly inbound and outbound tasks if there is a work to do. Because I cannot guarantee that will always be a double cycle or mixed cycle. I can't guarantee it. It depends on data. So I need to have, let's say, separate exit that maybe if there is nothing. So am I looking for the outbound? I want to use max wait timer. So I want to wait for outbound for a specific time. And if I don't find it, I want to move the second destination. So I want to move it like this. So do the inbound, Okay, you did it. Now check for outbound. If there's nothing to be taken out of the rack, okay, let's check. Maybe I can do some put away and some inbound task. Maybe I can do it like this. And the same should go from this perspective as a method for inbound. But maybe if there's nothing for the inbound, maybe I can take something out of the rack. So in this case, I will also use the max wait timer, remove set label, second destination, and then check it here. Yeah, so in this case, this is, let's say, I have some palette, and this check other task. Yeah? This is how it would work here. So I have the palette, and I can check the other task. And now, we need to look out for it. If I run like this, I would have infinite loop in FlexSim, and most likely my model will be shut off. Why? Because look how this logic works. Let's say I start with the model, I go for inbound, looking for work, 0 second in this case for waiting. Okay, nothing to inbound, check outbound, nothing on outbound, check inbound, check outbound, check inbound, check outbound. And I always have here time 0. So I'm circling looping all the time with 0 seconds, so I have infinite loop because time is not moving forward, because I'm constantly checking for work and there is no work there. So somewhere I need to set some delay here. So this token would loop. Let's say I will put this here 5 seconds. So I will then recheck it every 5 seconds. So now I resetting and running, yeah, and you can token be filled and be move, checking forward. Usually, it needs to be put somewhere. In this case, inbound or outbound, and wherever you put it, then this task has a higher priority because token waits for the task there. So if the task arrives, it is found first because it waits there. So whenever you put the delay, then you will have the higher priority there. In this case, for me, the inbound has the higher priority than the outbound. And if I recently run it, I will have the first outbound task. The ASRS is moving this. Let's see, puts on the rack, and it travels here. Let's check its IQRS. This is my palette. And this is what I want. So the logic works. What we don't have here yet is here. We need to loop it because we only create the outbound task for the first palette. We need to loop it. So you create the task. So again, you need to increment. In this case, it's going to be the outbound row. Outbound row by 1. Let's still check if this. So it's not inbound. In this case, it's outbound. And here is also outbound. Outbound row. Outbound row. Yeah. First delay palettes, the same. We just change inbound to outbound everywhere. It's outbound. Here is outbound. Here's outbound. And here is outbound. And in this case, please remember second column because table is structured differently. And now we have it. And I can again loop it to the SKU because I need to then check again which SKU I want to take out of the warehouse. And we'll have sync there. If you took everything, it's finished. Important thing that you need to remember is that if you use the push logic, push to list, the token waits there until somebody pulls this task. So if you want the token to continue here, you should use max wait timer and keep on release, on release, the token can move here and then do the next loop. So in this case, what we did here is we changed how we controlling the ASRS. And now the ASRS has its own logic. Is here. So let's say you can create the algorithm of how this should choose which task should be next. And you can prioritize it however you want. For example, so the more parameter you add to the list, the more option you have. Because, for example, we could add, I don't know, bay number or level number, and maybe sort it through the bay or level. Maybe you have the ASRS that has 2 places for pallets. It can take 2 pallets at a time. Then we do it differently. Maybe you need to do some reshuffling. So, for example, when you do the outbound and you have double deep pallet, maybe you need to create the extra task, and this task that you'll be reshuffling or shuffling, moving, or whatever you want to call it, because you need to take the something that is ahead or before the pallet you need. So with this list, it gives a huge, let's say, flexibility in how you want to handle the logic if any resource needs to choose something. So as we said before, we have created from the perspective of the ASRS. It's much easier to understand the process like this. Again, imagine you are the ASRS. I'm making the inbound. Yes, there is something to inbound. I'm making the inbound task. Okay, I finished. What should I do next? You finish inbound. Let's check. Maybe there is an outbound movement that I can do. If yes, do it. If no, check inbound again. Yeah? And this is the logic that we are doing here. And because of it, this is also inbound outbound is a very good framework if you have data with timestamp. Yeah, so I have some historical data, or maybe you, create some scenario creation tool in Excel. It's always easier to make scenarios in Excel, or maybe you want to do it in Copilot with something. Create a scenario, put it in FlexSim, test it, run it. Yeah, test it with timestamp. Let's see what will happen there. So as you can see, not a lot was built in terms of objects, but in terms of logic, we did a huge step forward in how we are controlling the system. Still, this is a very universal model. So if this warehouse will be bigger, I will just copy everything. Yeah? Of course, we need to add sync there because we need to have the exit for the outbound pallet. There. Yeah? We need to have the exit. So still it works. And one remark here. Yeah? Let's say you're creating the model on the real data, yeah? Or on some data. You have inbound, outbound based. It most likely will happen that these data are not 100% correct. So for example, in this case, it can happen that I'm creating the outbound task for a pallet, and this pallet is not in the warehouse yet. Or maybe this pallet was somehow removed from the base stock. Or maybe someone forget to ask someone to put it there. Maybe you have mismatched dates. Yeah, you have outbound for Monday, and you have base stock from last Friday, and somebody moved something when it was the weekend. It can happen. If this happens here, you can check it, the find item, because find item also have max wait timer. So if you choose to max wait timer and choose, for example, to release token on the second destination, this is the logic when the pallet has been found. And then you can write the logic. How would you like to handle these exceptions? And you can handle like this. Okay, nothing happens. Just don't create this task. So it will skip the problem for you. Or maybe you want to create this pallet in the warehouse somehow. It's just there, magically appear. So because you want to have the correct number of moves done by the ASRS. Yeah? In this, with this find item, you can be prepared for these mistakes. Maybe it will be there. Most likely, usually 1-2 pallets are missing because of the different timestamp or because of how WMS is working. Maybe the pallet was unroute in this time where the snapshot of the stock was has been made, it can happen. Yeah? So please, with this, you can very easily be prepared that maybe I will have some discrepancies in the data, and maybe I can do it like this. Yeah? Okay. I think this concludes today's part. So we will focusing more on the logic of controlling a different system, of creating the way of algorithms of how those systems should work and how we can control it. Yeah? This is just a framework. You can put much more details to it. And by adding the details, I mean adding more fields on the list with more parameters that you will use for choosing what should I do next. With this list, the same logic would apply for, I know, the AMR or AGV. I want to look for the work, look for the closest work. Yeah? With the list, you have a lot of different fields, even predefined one, like for example, distance. And then you can look for the task that is closest to me. Especially if we are talking about the AMR or AGV. And I want to create a task. I mean the task that is the closest one to me. Or for example, the queue size. By queue size, as if you are handling the different buffers or different conveyors in this case. Let's say you have a multi-level conveyors and ASRS is taking the pallet for multiple levels. Choose the pallet from the conveyor that has the biggest queue, so it's the most occupied one. Yeah? A lot of these are pre-built, and you can use it really. Okay? So list, very good tool. Whenever you know that in your logic you need to choose something from multiple elements with some parameters, with some logic, list is your friend. Especially that if you want to have changed the logic, sometimes changing the logic is just adding different order or changing direction. You can be ascending or descending and checking. It's a very quick, easy change that you can do, and it can completely change the logic or the algorithm you're doing, and it's pretty easy and pretty quick to do. Okay. So I think this concludes our building part, automatic warehouse. We added a lot of logic. We're adding more and more details there. We'll continue on our next session, but maybe we have some time left. Maybe you have some questions. Maybe you want to ask about something. Maybe you're building something. It can be questions about warehouse logistics. It can also be questions from different perspectives. Let's say general FlexSim. I'm here with you. I can help you. If you have different questions, if you're looking for some help in model building, you can also call us. You can schedule a different workshop with you. And this workshop is always, let's say, direct know-how transfer. So we'll build something with you. We can help you with your model. We can help you with your cases. Just please reach us, and we're pretty sure to find some date for you. Okay. I don't see any questions in the chat. So thank you for attending. I hope we meet each other on our next part 3 of automatic warehouse. I think it's going to be in a month or something. Please follow us on the LinkedIn, follow us on our webpage. I also invite you to our simulation business tool. We have the schedule there. I already seen my colleague put the links there. You can go. You can meet us in different places in Europe, in Czech, Slovakia, in Poland. I hope we can meet face to face. Thank you very much for attending, and I hope we see each other on our next part. Thank you very much.